आज ही डाउटनेट ऐप डाउनलोड करें। डाउटनेट पर होगा अब आपके सभी मैथ्स, केमिस्ट्री, फिजिक्स और बायोलॉजी डाउट्स का सफाया। बस अपने क्वेश्चन की फोटो खींचो, उसे क्रॉप करो और तुरंत वीडियो सोल्यूशन पाओ। डाउनलोड नाउ।
So what is the question here? Question is explain the following giving an appropriate reason in each case. Here O2 and F2 both stabilize higher oxidation states of metals, but O2 exceeds F2 in doing so. This is the first question. Second question is structure of xenon fluorides cannot be explained by valence bond approach. So we have to give an appropriate reason for this. So let's start with the first part of the question, which is, if I describe the first part of the question, I'll write here O2 and F2 both O2 and F2 both stabilize higher oxidation states of metals due to their strong non-metallic nature. But O2 exceeds F2 in doing so because O2 has tendency to form multiple bonds with metals, as it form O2 minus ion, which has a stronger attraction for higher oxidation states. As compared to F negative. So this is the best reason to defend the first part of the question. What we have, the question is asking about O2 and F2 both stabilize higher oxidation states of metal, but O2 exceed F2. Why O2 exceeds F2? This is the question. So I have given the best example. O2 and F2 both stabilize higher oxidation states of metal due to their strong metallic nature, but O2 exceeds F2 in doing so because O2 has tendency to form multiple bonds, but in the case of F2, it does not have tendency to make multiple bonds. So this is the reason why O2 exceeds F2. Okay, so let's go to the second part of the question. Second part of the question is structure of xenon fluorides cannot be explained by VB approach, which is valence bond approach. So we see this. According to the valence bond theory, completely filled orbitals do not take part in the bond formation. Okay, so what we have, xenon has a complete octet, so there is no unpaired electrons in any of its orbitals. So therefore the structure of xenon fluorides cannot be explained in terms of valence bond theory but requires VSEPR theory. VSEPR theory is, as you know, valence shell electron pair repulsion theory, okay, to explain the involvement of lone pairs in bonding. So I'll write it here to make you more simple, you can easy to understand. So the reason to defend the second part of the question is, according to the valence bond theory, completely filled orbitals do not take part in the bond formation, okay, do not take part in the filled formation. Xenon is the element here. Xenon has complete octet, as you know, octet. So there is no unpaired electrons of any of its orbital. There is no unpaired electrons in any of the orbitals. Therefore, the structure of xenon fluoride cannot be explained in terms of VB theory, which is, you know, valence bond theory, but requires VSEPR theory to explain. VSEPR theory is which theory? As you know that VSEPR theory is valence shell electron pair repulsion theory, okay. So here we complete the statement, theory to explain the involvement of lone pair, in bonding. Okay, I hope you get it. Thank you.
क्लास 6 से 12 से लेके नीट IIT JEE मेंस और एडवांस के लेवल तक 10 मिलियन से ज़्यादा स्टूडेंट्स का भरोसा। आज ही डाउनलोड करें डाउटनट ऐप या व्हाट्सएप कीजिए अपने डाउट्स 8400 400 400 पर।